Friends, now I will show you how to calculate the length of the droppers in various span, standard span, and later we will discuss if the span is not standard, then if the encumbrance is not same in the two end. So step by step we will discuss it. I prepared the notes in the railway training school and the copies with me. Due to crisis of time, I am pasting my notes here. As I have prepared it, I know it's top to bottom, so I can. These had been done by me, so I am well aware about the design. Here, what we have done in the two pole, we erect a string. Due to its weight, it will take a shape of a parabola. There will be some sag due to its weight, and you know the formula of a parabola is x square plus bx plus c, and we have to find out the length of the dropper at x distance from k. So other end will be how much? Other end will be a minus x. The span is a. So we have given the first dropper in the x distance, not first dropper, any dropper in the x distance. So remaining distance will be a minus x, where a is the span. Now at point k, x is equal to 0 and y is also 0. So if we prove the formula, we can find out the value of c. C is equal to 0. A, B, C are three constants. Next, at L point where x is equal to a and y is equal to 0. So at that time, we can find out the value of b is equal to a into a capital A into small a. Small a is the span, and capital A, the value of the capital A is given by p by 2t, where p by 2 is the weight of OHE on each mast, and T is the tension. Or weight of string per meter. You can tell weight of OHE per meter. If you think about the OHE conductor, and if you think any string, then it will be weight of string per meter. So the equation becomes y is equal to x square minus a into ax. If you take common the ax, then in the bracket it will be x minus a, or minus y is equal to ax into a minus y minus y, because our sag is in the minus direction, y direction but minus. So it is taken minus a is equal to ax into a minus x is equal to minus, put the value of a p by 2t into x into a minus x. So now it is clear. I think the formula. Now we will put the value of x for the distance of the dropper, and it will give the result. Let's see how. We know that from the previous video, the distance of first upper is always 2.25 meter. So this distance is called B. This distance is called B. Now first we have to find out the catenary sag, that is H, at O point where the B dropper is fixed. How to find out H? We'll take moment in the point O. So it will become T into H. T is the tension and its distance from the line of action to O point is H, plus, because both the moments are plus, C into B means catenary weight up to B, and its distance will act in the middle of the distance, it is B by 2. And the third moment, that is reaction of OH P into A by 2, and it is acting in the B distance from K point to O point, the distance is B. So the equation we can find out that B by 2T, it is common, then P into A minus C into B, where P is the total weight of OH, A is the span, and C is the catenary weight, and B is the first dropper distance. So easily we can find out the value of H. Friends, we now will find out any length of dropper at any distance from the mast. The first dropper is 2.25 and the second dropper, which is divisible by 9 meters of a span. A span can be divided by 9 and 4.5. That will be the distance of the second dropper will be 6.75 plus 2.25 the first dropper, so it is 9 meter. The X is 9 meter. But for other span which is divisible by 4.5, the first dropper is 2.5, but second dropper is 9 plus 2.5 11.25. The second dropper will be 11.25. Then third dropper will be 11.25 plus 9, 20.25. In this way you can find out the value of X and put it in the formula, and it will give the length. What is the length? From the figure we can see the value of the the length of the dropper at X distance from mast after the first dropper is encumbrance minus catenary stagger minus again catenary stagger in the X distance. First is the 2.25 meter distance is H, but Y1 is at X distance. The catenary stagger is Y1 after H. And next contact wire will sag after the first wire. The remaining sag is Y2. So length of the dropper is E minus H minus Y1 plus Y2. Now encumbrance is normally 1.4 or 1400 millimeter, and then it can reduce in the overland structure under the bridges tunnel. So according to that encumbrance, you have to find out the length of the dropper so that your OH profile is good. Now how to find out Y1? Y1 is from the parabolic formula you can find out. Here given the formula again, P minus W by 2T. Why P minus W by P minus W? Why? Because P is the weight of the total OHE and W is the rest weight on contact wire. Small weight will still remain after the first dropper. The amount is W. So P minus W is the weight now working divided by 2T into X minus B into A minus X minus B, the parabolic formula. From there you can easily find out the y1 value, then put the y1 value, it will give the length of the dropper. The question is, what is w, value of w, how to find it? Y2 is w by 2t, because now the weight on contact wire is only w by 2t x minus b into a minus x minus b. For a 72 meter span, the sag is 1 by 1500 into 72 meter is equal to 0.048 meter. Also, we know the formula of sag, WL square by 80, where W is the weight, L is the span, and T is the tension. So ST is equal to W into L square by 80. L square how much? We know, we can find out the L. L means now the span after the first dropper. What is the span after the first dropper? Both side B is reduced, so 2B. From A span, 2B has reduced, so it is 1 A minus 2B. The span is now A minus 2B. WL square. So L has become A minus 2B. W A minus 2B whole square by 80, where T is equal to 1000 kg, or W is equal to 0.084 kg per meter. Just reverse. For the S2, we have seen for 72 meters span it is 0.048 and it is 0.084 kg per meter. To remember it, you can easily remember it, keep it in your mind. This is for 72 meter span, but for any other span, it will become A by 72 whole square. A means span by 72. If it is 72 span, then 72 by 72 is equal to 1. So 0.048. But if it will change, then this value will also change. Thank you, friends. In the last time, I want to remind you one thing. I was the chief instructor of All India Training School, Chakradharpur, and I prepared all these notes with my own experience and knowledge. So I have the authority to share it. Due to shortage of time, I shared it here, the little text. So good night. Thank you all.